Hello, my name is Louis Feinstein. I am the Global Sales Director at Dassault Systems for High-Tech Solutions. Thank you for joining today's webinar on electromagnetic simulation reimagined. Today's presenters are Derek Nunes, Global Sales Manager at Vias 3D. Derek is a passionate salesperson who worked in sales at CST America before moving to Dassault Systems, where he worked in partner sales enablement. Derek is based out of Boston and recently joined the Vias team to lead their Emag sales division. Thank you, Derek. Our second presenter is Monica Block, who is an industry solutions experienced senior manager with Dassault Systems, working in the high-tech group with high-tech customers worldwide. She has over 15 years experience in the simulation software industry and has received her PhD from Technical University of Darmstadt, Germany. Derek, take it away.
Talk about the company I work for, Vias. Vias is based out of Houston, and we are a platinum Dassault partner who sells every product that they have. But one of the things that we focus on specifically is what we like to call scientific simulation, really accurate and representing as far as real world simulation results. So that's something we focus on pretty heavily. And when we're talking about simulation, there's all sorts of different types, different disciplines, different types of physics. So we have structural, we have, fluid flow, thermal, all sorts of things. But for today, and the purposes of this webinar, we're talking about this right here. So when you see CST, just really quickly, that's, as Lou mentioned, that's the company I worked for, which focuses heavily on the EM side, the electromagnetic side, and we're going to dig into a few of the more interesting parts of that EM simulation package today that maybe not many people know as much about. So I wanted to put this slide on here because there's, when it comes to EM simulation, a lot of people, the first thing they think of is antennas, and they should. So we're talking antenna and antenna array design, radar cross section. We're talking the Internet of Things, EMI, EMC, and that has to do a lot with our full wave 3D EM solvers. But I want to tell a quick story because I'm still a salesperson right now. I'm a sales manager who kind of helps sell this product globally for Vias. I'm learning all the time, but last year I was trying to get into a 5G company, basically. And they already had one of our competing solutions. And it was really tough to distinguish ourselves, especially since they already had tools in there. And what ended up getting it done was I was on the phone with this prospect at the time, and they wanted to look at their products holistically. They had some high power devices, and I was showing off the full wave 3D EM solvers, our time domain solver, our frequency domain solver, things to look at it just electrically. And it just kind of so happened that he mentioned to me that he was ordering one of our competitive tools for thermal. So during the demo, we were doing about a demo a week, trying to see if we could convince them to look at our product. When we mentioned that CST had a thermal solver, he basically immediately put a stop on the licenses he was going to order for a competitive product and switched the whole evaluation and demo because he wanted to look at CST's thermal solver. Now, I felt a little guilty. One, I should have mentioned it beforehand. I was supposed to focusing on the EM side, and that's really what made the sale here, was the fact that we had a thermal solver included in another product called Spark 3D. So even after selling this for 7 to 8 years, I realized that people are looking at more than just the EM side of things. There's all these other effects. If you're running a lot of current through something or high power, how hot is it going to get? They need to know everything. So it kind of broadened my scope a little bit. And when we say Emag reimagined, it was reimagining it in a way that is comprehensive, just based off this tool, CST. There's so much to unpack there that it was a good learning experience for me. And it also, in this series of webinars, it made me think maybe we should talk about some of these things, because maybe they're not the only ones who don't know about this product functionality and these features. So to quickly recap, I've done a few of these webinars with Lou and everyone else at Dassault when I was still working there, but I hear a lot when I'm on sales calls, because I'm on them every day, is CST STUDIO SUITE, it's the full name, is an antenna tool. Now, that is not the wrong answer, but it's not totally right, because in my opinion, it might be a little salesy, it is the antenna tool. And that is because we have complete technology. You can see on the right, we have the time domain solver, frequency domain. When we say complete technology, we're just talking about having the right tool for the job. If you have a broadband application, if you have a narrowband application, if it's electrically large or it's highly resonant, all of those things are going to depend on which solver you're going to use. So having that in there allows you to you could do an antenna on a battleship, or you could do a very small, tiny antenna on someone's phone or something else. So it's not just an antenna tool, but it is the antenna tool on the market. But really what we're talking about today is, we've done a million webinars on antennas, is some of the other things that I've realized that are very important to my prospects and customers. So, and a big one we're doing today is multiphysics, the thermal side of this, which is really a beautiful solver because it doesn't take long to run. It's included in the tool. You don't need to be, a mechanical engineer or a thermal engineer. You can be a double E, an electrical engineer, and just find out. Sometimes you need to know how hot things are going to get. So that's one of the big things that we're going to hit on today, but also a little bit for filter design and a few others as well. So just want to set that stage. So when I still worked at CST, we used to have this event that we would go to. And when this solver was introduced, I actually worked pretty closely with that person. He happened to be in the same office. I asked what this solver was about. And to break it down simply, Monica, who's going after me, is going to go a little bit more into the details, was that it can handle every type of thermal energy transfer. We're talking conduction, convection, and radiated. So it is extremely helpful. We can do electronics cooling. We can do basically whatever you would need for an double E or an EM engineer to find out how their product is going to be affected thermally, and to do it really quite simply, where you just change the solver from an EM solver to the multiphysics solver at the top. And that goes for steady state and transient as well. Again, it is included in the tool, and you don't want to have to be an expert when you're trying to do something. Most times electrical engineers, if it's anything high power especially, they just need to know how hot it's going to get and if they're within the limits of what's okay. For Spark 3D and Fest 3D, again, Monica is going to go into this in a little bit more detail. This was another tool when I sold that story before that was really, really important for them. They did RF connectors that were high power. Now, this is when we're talking about RF filters and antennas, but it's really for any high power microwave sources. Which when I was still at Dassault, it was really, really big for satellites, because it can also do avalanche breakdown multipaction. And if you're going to send a satellite into space, you can't really send anyone up there to fix it or work on it afterwards. It has to work right the first time. And very expensive devices. So knowing how that's going to work with this RF breakdown and avalanche is really important. And Fest 3D comes from the same company originally, AuroraSat. And just to put it simply, it is the best tool on the market for waveguide filter design and high complexity multiplexers, many things like that. So, and last but not least, I haven't mentioned this yet because this is one of the simpler stories, is we have a tool called Antenna Magus. Now, in a nutshell, this really is a tool of about 400 parameterized, ready to go antenna models that are validated, where if you're using an off-the-shelf antenna, if you're an antenna designer or an RF engineer, and you're doing the same thing, making little tweaks, maybe you don't need this tool. But if you're ever doing some custom antenna design where you need to get creative, where you kind of want to throw, some antenna ideas against the wall and see if they stick, this is the perfect tool. I mean, you really go inside, you can type in Bluetooth, you can in the search bar, and it'll bring up every single antenna model that you need there. You can type in patch, horn antenna, array, and it really is just a tool that speeds up your workflow from the very, very beginning if you're not sure exactly what type of antenna you need. And the whole point essentially of this is we do have the full wave EM solvers here when we say Emag reimagined. But between the thermal solver that's included in some of these supplementary tools, we go so much farther beyond those just standard best in class, full wave solvers. So in light of that, I would like to thank everyone and put my email and phone number on here. Please feel free to email me or friend me on LinkedIn or give me a call. But in light of that, I would like to hand it off to Monica Bach.
Thank you for the kind introduction. I would like to also mention or highlight two things beyond or complementing actually antennas. And as a cherry on the top, I would like to show you as last point the cloud compute, which recently has been made available. The two things I would like to show you beyond antennas are the feeding networks and filter design and the device thermal performance, as Derek already introduced. Thinking about feeding network and filter design, maybe we should have a short look at what is this about. You may have heard about the public auction of transmission frequencies, which already shows you that it's a highly regulated topic. That means if we look at this here, we have a crowded spectrum, small frequency gaps where our transmission devices should work. In order to ensure this, we need devices, these highly selective filters, which make sure that our operation of the frequency stays within these bounds. That means the filters regulate, first of all, what is transmitted from the antenna to the world, let's say, but also what is received by the antenna. In order to make the antennas and later on amplifiers life easier, it's good to filter out unwanted frequencies. Therefore, you see filters are an essential part of the device or equipment system. And I would like to show you in the next two slides some advanced capabilities Simulia CST can offer. The first thing is a filter synthesis tool, which actually generates the 3D geometry. So what you would do here is you would specify characteristic points of your desired frequency response, as for example, pass bandwidth, stop band attenuation, and some things like that. Then you can also specify the order of your filter and the topology. And then Filter 3D gives you basically this coupling matrix here, which already is good information about the desired filter, but it also hands over to you a 3D geometry, which you can then use to simulate in the full wave solver, for example, frequency domain solver. So that's about the synthesis. If we go for analysis, it was already mentioned that we have FES3D, which is a very quick analysis tool. So you see here that you can set up a filter or multiplexer with different blocks where you see the resonator blocks. That is quite nice because it's very quick and you get the filter response quite quick. But there's also some other nice point in this, because this FES3D can be used as a block in the circuit and systems tool of CST. You see here you can have a block in greenish here, which is our FES3D block, and you can attach this to another 3D block, which is your CST or your antenna simulation. Therefore, you can actually have a combined view on your system, which gives you certainly more insights into what's going on in your device. As Spark 3D already was mentioned, let's have maybe a shorter look into that. So Spark 3D, which you see here in the middle, the icon, is a tool for breakdown analysis, which especially or often is used in combination with filters. As mentioned earlier, so often this is for satellite or filters going to satellite, but also, for example, in base stations that could be of interest potentially if you have maybe high power going through. So in terms of breakdown, we have different types of breakdown. So we have breakdown in vacuum. That is typically what's important if you send something to space, or you have breakdown in gas, which is important if you're on the Earth. So what you would do is actually you can run your filter here in a full wave solver, like a frequency domain solver, as shown in point 1. And then you just simply load this already existing electromagnetic field distribution into Spark 3D. There you specify the high power analysis settings, like, for example, which gas you have, which pressure you have, and so on. And then the tool gives you the breakdown power levels for the full circuit, or also for each of the cavities, depending on the pressure you see here. And then last but not least, it will also give you an indication on where the breakdown would occur, such that you can maybe redesign your filter, maybe enlarge some parts, such that breakdown will not occur. Because if that occurs, it would maybe deteriorate electromagnetic performance, or the device can be damaged, and this is something you don't want. So with this combination of the different tools like Spark 3D, Fast 3D, and Filter Designer 3D, you have a really unique offering on filter analysis, I would say. Let's come to the next point, to the device thermal performance. Thermal issues are not new in terms of electronics. They are with us as long as electronics exists, but they become more important. That is for different reasons. For example, if we look on the left-hand side, we see the base station antenna of a 5G mast. There, thermal analysis becomes important because we have an increasing integration by packaging the antenna, the RF front end, and the power amplifiers, and all electronics in the same package. So we see here on the left, we see the patches of the patch array antenna. And in principle, behind that, we would have the PCB board with the electronics component and the power amplifiers, which are generating the heat. And due to this increased integration, it's important to have a look at the the cooling strategies. That means, are passive cooling strategies still enough, or do we need to enhance them by fans and some active cooling strategies, as you see here? As it was already mentioned, the Simulia CST thermal solver has a conjugated heat transfer and a Navier-Stokes CFD solver. And you get basically here, you see the heat flow, and of course you get also the temperature out of that. There's a strong link between the electromagnetics and the thermal simulation, which you will see later on as well. Okay, so we have discussed the increasing importance, for example, for this antenna base station because of the integration. But what about consumer electronics, as you see on the right-hand side, where we have a mobile phone? For this and for other electronics components or consumer electronics components, we have a similar problem. We have increased packaging densities. You see, if you look at the components of the phone, there's almost no space really. But still, you have components in there which generate heat, and you have to make sure that nothing is breaking and you don't have any damage of components in this. Therefore, it's important to see if the device still works or if some parts are maybe overheating. On the other hand, there's another thing important. There are regulations that on the skin of this mobile phone, the temperature has to be lower than 45 degrees. So in order to fulfill these regulations, we have to make sure that this is really the case and do a thermal analysis. So you see that becomes more and more important. Let's have a look at the different levels on how this could be tackled. So there's one level which probably some of you may already use. This is the circuit schematic level, where you see here the JEDEC model of a chip, for example, where you have a junction where you have your heat source, which is probably a chip. Then you have some nodes, which is maybe the contact to the PCB or the contact to the case. And in red, we have the thermal resistors, which are either objects conducting the heat or maybe certain contacts there. The circuit description is quite nice because it first of all allows you to understand the heat flow in a very simple manner, let's say. On the other hand, you can also give this to users or colleagues without disclosing proprietary information. Of course, at some point you want to have a more detailed analysis than that, and then you can go to a 3D analysis. And in principle, you can recognize similar things here as well. So you have a heat source somewhere, which is your junction, and then you have objects where you specify a thermal conductivity, which are then thermal resistors, and then you have some nodes where you connect to the board or to some heat sinks, for example. By the way, these thermal resistors in the simulation, in the thermal simulation, do not have to be necessarily really a geometry, because sometimes it's maybe a little unfortunate to model this as geometry, but it could be also just a contact condition between, for example, the chip and the PCB board. And these contact conditions can then describe either thermal resistance or thermal interface material with an equivalent thickness. Okay, so we have now discussed the levels of thermal simulation. Let's have a look at some very unique and, let's say, convenient features. And that is actually the electromagnetics thermal coupling within Simulia CST. So for example, if you have a PCB setup like that, potentially in PCB Studio, you can generate a simulation project more or less with one click, actually. And this simulation project setup automatically sets up the 3D geometry, not only the geometry, but it also imports the losses which are, for example, generated in the components or in the board. In this setup, you can also decide whether you want to leave the printed circuit board represented with the different layers, or if you want to just have a single brick. In most of the cases, a single brick is sufficient, because the losses in the PCB are usually much less than the ones in the components, so you can easily simplify that. The simplification, as shown on the right in the dialog, can be quite easily done by just telling the software you want it to be simplified, and then it automatically generates a single brick out of that with an anisotropic thermal conductivity. Anisotropic in that way because along the layers of the PCB you would have a good conductivity, and transverse to that you would have not so much conductivity. And then you have quite an easy setup for your thermal simulation here. And of course, you can also load in other, let's say, magnitudes as power loss density from a previous IR simulation. You can just import them or load them as field imports. So it's really a very convenient kind of one-click solution to go from a PCB simulation to a thermal simulation. Okay, then let's come to the last point, which I would like to mention, because I think we had a lot of fun finding this out ourselves, or because that has been made available recently, and that is the cloud compute, the 3D Experience Cloud Compute. And maybe as a disclaimer, this is potentially most interesting for customers who don't have time and manpower to set up their own high-performance computing system. For that, I think it's really valuable. So how does that look like? Let's have a look. So we're here in a public cloud instance where we're looking for the CST connector, or connector for CST. That basically starts from the cloud, the CST Studio Suite. You see it opens and you load, for example, your CST file, make some changes, whatever you want to do here, and then you save this to the 3D Experience platform. That step actually is necessary to see the simulation object or your CST files later on the 3D Experience platform. So that's the so-called, let's say, power by upload. Now we look for the simulation manager, and that is actually the app which is controlling the cloud compute. let's just quickly go back. As soon as you look at the simulation manager, you see that here on the left-hand side, basically all models previously uploaded with CST Power BI are listed. So the only thing you have to do in order to make your model available here is to upload this as shown in the first few minutes of this video. And as soon as you have it there, you can basically send it to the cloud compute. Let's narrow our selection down to the GPS patch antenna. We can run it either from here or from here and send this to a cloud or to a cloud compute instance. I would like to stop here because we should maybe spend a few words on how you can compute or how you can run this in terms of license. You see here that we have tokens and credits. The tokens are basically reusable, so they are checked in and checked out, so like the license features for the solvers. But there are also credits, and they are consumed. So I would say they are probably for balancing out peak compute times. Then we have the different solvers available. As you can see here, for the moment, these are only the high frequency solvers. And of course, the others will come in later stages. Then you can also specify what configuration do you have, if you want to use a GPU, if you have a big simulation. Here we have just a small simulation, and therefore we run it. You see it's cute, but now it's running already. And in principle, you can, by clicking on this upload button or update button, you could get intermediate results if you have a long-running simulation. But here we have a quite quick simulation where we get directly the results, like 1D results, like port signals and energy and so on in this simulation manager. You get also the the log file, which tells you, first of all, where it was calculated and also what hardware was used and so on. So as you might know from the CST simulation. And you can also look at it in Physics Simulation Review, which is actually quite cool. So you see this here, this is a web app, which is available on the 3D Experience platform. So in principle, you can also look at it from your mobile phone if you want it. And in order to look at these results, you do not have to have, let's say, the CST Studio Suite open for that. But you can look at here 0D and 1D results, similar to as we've seen before, the S parameters, and if we want, we can also look again at the port signals and energy and so on. But we can also look at the far fields, as you can see here, and at other customized results, as for example, the surface current here. And last but not least, at some point you might want to have the full CST file or CST data available in order to open it there, and then you can download this to your hard disk if you want it. Yeah, that's in principle all I wanted to show you. So I think this is quite nice, and I would like to thank you for your attention, and that's everything I wanted to tell.
Well, thank you, Derek and Monica. It was very, very interesting. We have a couple of questions that some people have put up. And one of the questions that comes up is the thermal solver part of CST, or is it a different tool with a different interface? Derek?
Hey Lou, thank you for the question. That's a good one. So the thermal solver is included in the base package of CST, and it's not a different interface. It's a nice ribbon GUI. So at the top, you could be switching between your EM solvers, but really, if you're doing some electrical analysis or EM analysis, when you're done with that, you literally just go to the top, click the drop-down menu, change it to thermal. It's super easy. It's right in the same tool. It's all native.
That's terrific. And we have another question. So on the same lines, is Spark and Fest 3D included also with the CST Studio?
I hope you don't mind if I take this, Monica, just from the sales side. No, it is not included. In the base package, we include a lot, but those are some specialized tools, so you would have to add that on, which would have a cost.
And
Yeah.
I think I have a question for Monica. You mentioned that thermal solvers can handle electronics cooling. Which technology in the thermal solver helps handle that specifically?
I think in terms of electronics cooling, it's very nice because the setup is quite easy, because you have already some assumptions which, let's say, a tool which handles also other things doesn't have that. So the assumptions are, for example, everything which is not determined as a fluid is automatically be considered as a solid. Then we have certain simplifications in terms of how the materials are defined and so on. And yeah, it's also quite nice because it automatically decides, for example, if you have, let's say, like a fan or so, it would use some turbulence models. But if you don't have that, it would automatically use natural convection, and the solver setting automatically decides what's the best setup. So this is quite nice in terms of automation. Yeah,
that's exactly right. And just to add on, I think for some electronics cooling, which she was talking about, like the fluid flow, I'm pretty sure our CHT solver would help a lot with that, the conjugate heat transfer.
Yeah.
Well, thanks, everybody. Thank you for attending this webinar. It'll be available on the web for replay. And if you have any questions, please feel free to contact Derek, and Derek in turn can talk to Monica if it gets really technical. And Vias has a great technical staff, and thank you for attending.